Okay, so we're going to talk about what is business analytics, how it's done, who's using it, and then we'll discuss a few challenges and tips that I picked up along the way that I'd be happy to share with you. Okay, so first, what is business analytics? So business analytics involves using tools and techniques to turn data into meaningful business insights. So it's using tools and techniques to turn data into meaningful business insights. So that data could be from spreadsheets or from traditional databases. It could also be from Twitter or from Facebook. And then we're using tools and techniques. The techniques might be statistical models or machine learning, something. And then the hope at the end of the day is that we get some business insights out of it. Now, if you look at this diagram, it looks pretty straightforward, right? But I don't think this does a good job of communicating the complexity of analytics. I sometimes, it sort of feels like this to me. So we get some good data coming in. We also get a lot of messy data that we have to scrub and clean up to make usable. And we also get a lot of garbage data along the way that just isn't really helpful at all. And then we kind of have to fight with the data, battle with it, to get something out of it. It just, sometimes it becomes a spaghetti mess, it feels like. And then because we have, garbage data or messy data coming in, sometimes on the other end, we do get some business insights. We also get a lot of noise that comes out. And sometimes if we're not careful, and that noise or that garbage that comes out gets used to make decisions, it can be harmful, right? So this, I think, does a better job of communicating some of the challenges that are faced when on analytics projects. Okay, so now let's talk about the types of analytics. There's descriptive analytics, which deals with what happened, right? So we're looking at historical information to maybe piece a puzzle together. An example might be we're looking at data from the previous quarter, or sales data, for example, and maybe comparing that data to the same quarter in the previous year. So we're trying to figure out what happened. And then there's predictive analytics. So that's trying to figure out what might happen. So we might use statistical models to do that. And then there's prescriptive analytics. So that actually involves telling us what we should do. So to get there, we might even use some of the descriptive analytics or the predictive analytics to then get to a prescription, right? We might recommend decisions based on some optimization models that we put together or some simulations, that sort of thing. In my opinion, I think all of these are important and they have their place, but as we go down this list, it gets more value added. I think that the best type of analytics are prescriptive analytics, in my opinion. Okay, just want to talk for a second about some buzzwords. So you've probably heard some things similar to business analytics, business intelligence, decision science, data science. I don't want you to worry too much about it. They all really support the same goal, and it's true, there may be some slight differences, but all are trying to get to the same end, right? It involves using tools and techniques to turn data into business insights, right? All of those help us get to that end state. Okay, so now we want to talk a little bit about the process, right? How we do analytics. What's the method? What are the methods that we use? So similar to the scientific method, we always start with a business problem that we're trying to solve. Some of the problems might be, how do we optimize pricing? What's the optimal price to allow us to boost our revenue? Or how might we segment our customers to tailor product offers to them? So there's a higher likelihood that they'll buy something. Or a problem might be solving bottlenecks or failure points in our supply chain. So we first want to figure out what problem we're trying to solve. The next thing we'll want to do is to plan the work. So we do some research on the problem. We maybe estimate the effort that's required to do the analytics on it, and then we'll build a business case to get support from our leadership or whoever's asking us to do this. And I know sometimes in the excitement of doing the analytics, we can sometimes skip this step, but I think it's important not to neglect it. It certainly doesn't have to take a long time to do this. A lot of this can be done in a couple hours, but I think it's still important that you don't make any commitments to do something until you've kind of figured out first if it's even possible, and then how much effort and money is going to be required to do that. So some of the things that we might want to ask about the data that we're needing is, first, is it available? Can we even get to the data? And if we can, what's the quality of the data? If it's garbage and we're not going to be able to clean it up, that's going to be a problem. And if it's messy, we still got to spend time to scrub it, so that's something that we need to be aware of. Another thing we might want to ask, is it granular enough? So if we're looking for sales data at the city level, for example, if we can only get it at the state level or the country level, that could be a problem. So those are some of the things that we want to think about before we get started, right? I think it'll save you a lot of pain later if you've gone through this type of research and this level of planning. Now, once we've done that, we want to put a business case together. This doesn't have to be complicated at all. It can be very simple. But what we're trying to do is to communicate to our leadership, whoever asks us to do the analytics, how much it's going to cost, and based on the costs, what are the benefits that we're going to get out of it. And I like to couch these in terms of good, better, and best options. You certainly can make a recommendation on which one might be most appropriate or what's the best use of money, but it's always nice to give people a couple different options. I don't know. I just think it adds a little bit of value. And then obviously, once we've shared this with our leadership, we don't want to move forward until we have their strong support, right? We don't want to make any investments until we get their buy-in, their approval. Okay, so now once we've identified the problem, planned out how we can solve it, and gotten, did some analysis or estimated what the cost might be and what benefit we might get for those costs, then, assuming we've got the approval, we can start getting to work. So what we want to look at doing is grabbing the data that we need, finding a place to store it. We'll want to spend some time cleaning it and scrubbing it, analyzing it and maybe visualizing it, and then interpreting it, right? In the end, we want to get those insights out of it. Some of these may happen in parallel, and that's okay, or some may be switched around in some cases, but you get the idea. Again, we're grabbing the data, we're storing it somewhere, cleaning it to get into the format that we need, and then doing the analysis and maybe some visualizations, and then interpreting what we get out of that to get those insights. Okay, so next, I want to just share with you some sample architectures. So how does this look technically? And this doesn't cover, every way that analytics is done. It's just some of the more common examples that I've seen. There's a million possibilities and permutations of this, but this just kind of gives you some ideas of some of the more common approaches that are taken. The first architecture example that I see a lot actually is what I call traditional analytics. So this is for big structured implementations. It supports lots of demand, but sometimes it can be stiff. And it's designed that way, right? So there's some governance in place to make sure that the data stays of good quality and that it's secure, and so only people that see the data should see the data and that sort of thing. So it's designed to be a little bit stiff, and so it can be more difficult to respond, but we do that because we need some level of control, some level of governance, right? So in this example, we're going to pull data from transactional systems, so data that's coming from our supply chain, maybe from points of sale systems, from finance data that maybe eventually gets reported to Wall Street. So we're pulling data from transactional systems using ETL. So this means extracting the data, transforming it, getting it into the format we need, and then loading it. We're going to load it into what we call our data warehouse. That's our reporting repository. That's where we're going to store our reporting data. And then what we'll do is we will point our tools, right, our analytics tools, On the front end, this could be Microsoft Excel in some cases, or it could be some of the new flashier tools like Tableau or ClickView. We point it to that data to then generate graphs or models or whatever it may be. Okay, another example is what I call big data analytics. I'm starting to see this more frequently. So this is for big unstructured implementations. It supports lots of demand, and it can support lots of demand really fast, right? So in this example, we might be pulling data from Twitter, from Facebook, from the web, maybe from message boards or sites or something. And we're pulling that data into a Hadoop cluster. We won't go into Hadoop here, but it's talked a lot about when we discuss big data. But Hadoop allows you to ingest lots of amount of data really fast, lots of unstructured data. And it also allows you to do some scrubbing on that huge data set that might be really difficult to do in a more traditional environment. And a cluster is just kind of a collection of computers that are working together. So they're all working together to analyze this unstructured data. And then we're pulling that data, in some cases, at least a subset of that data that we've maybe now structured, or we've cleaned up, we've scrubbed, into our data warehouse, which we talked about in the previous example. This is like a reporting repository, right? And again, we're pointing some of our tools on the front end, whatever it may be, Tableau, ClickView, Microsoft Excel, we're pointing that to our data warehouse. My guess is that we'll see models like this more and more often as the volume of data that comes in continues to grow, and as we see more unstructured data coming in. Another example is what I call the Excel power user. I don't want to dismiss this at all, because this actually happens a lot. It still can be analytics, right? Even though we may not think of it that way. So this model is affordable, but it may only be for a limited number of users, but it does allow you to respond to needs really fast. So an example might be maybe your boss needs you to, pull in some data from several spreadsheets or from a Microsoft Access database that they have somewhere, and maybe a little bit of data from the web. I want you to do some research, analysis, try to solve a business problem that you can do in Excel. Excel allows you to do it. It's not a huge data set, and you can easily, when you're done, when you've done ran your pivot tables or built your statistical models in Excel, or you can even do optimization in Excel too. Once you've done that, all you have to do is then email out the file, share your findings, and be done with it. I see this a lot, and it's still certainly can be analytics. Okay, now I want to look at a case study that I really like from Capital One. Now, they're not the only one that does this, but they're one of the first people to try it out. So what they did was take publicly available credit and demographic data. So this is data that you could get off the web, right, or wherever, right? And they figure out and build models to determine how to segment customers, and then what products to tailor to them. So based on someone's demographics, where they live and how much income they make or their credit history, based on historical data, they can figure out what those types of people bought and then tailor future offers to new customers. So in this case, what happens is, as a customer calls in, or as they call a customer, right before that customer even says hello, that model's running in the background against that customer's information, and they're figuring out, okay, based on what we saw in the past and based upon who this customer is, we think they are most likely to buy this type of product, and we ought to offer them this type of credit limit. And what's interesting in this model is that it was able to predict what a caller might want to buy with greater than 70% accuracy. That's huge. So you're not just taking this really broad approach, right? You're tailoring offers, very specific offers, to certain types of customers. A really cool example. There's a million others. This is just one example that I really like. Okay, now we want to talk about some of the challenges that you might face. The first is that data often needs a lot of cleaning. We've talked about this a little bit already. But what I found is sometimes it's not so much the analysis that's difficult. It's actually getting the data ready, cleaning it and scrubbing it, and getting it in a format where you can do that analysis. This can sometimes be the most frustrating part of it, right? Just having to clean the data to get it ready. Another challenge is that data is getting much more unstructured. So it doesn't all come from relational databases or from spreadsheets. We could be getting PDFs, music files, pictures, movies. We even talked about data that's coming in from Twitter or from Facebook. It's getting much more challenging, right? It's in a variety of different formats. And to add to that, data volumes are growing much faster. So not only is the data, a lot of it messy, it's coming in a variety of formats, and it's coming really fast. Traditional models, like ones that we mentioned, are having difficulty handling that. I like this quote from IBM. 90% of the data in the world today has been created in the last 2 years. It's just going to continue to grow at pretty alarming rates. And so on top of all this, what we need to keep in mind as well is that markets are becoming more competitive, right? It's demanding decisions faster if we want to stay competitive. So not only do we have more difficult data and more data to work with, we've also got to be able to produce insights at a faster rate in order to compete. Another challenge, good analytics doesn't always solve bad business process. So if we have a process that's producing poor data that we're using for our analytics, the insights that come out of that might be meaningless or even harmful if we use them to make important decisions. So if we have garbage coming in, we might have garbage coming out. The only silver lining to this is that based on the garbage that comes out, you might then realize that you've got to make some adjustments to how you're collecting data on the process. That's the only silver lining that you might want to think about. Okay, just as far as a couple tips go, the first one that I think you ought to keep in mind is that you always ought to be providing recommendations and not just data or information, right? So we get insights that come out and we can use those to help provide recommendations to our business. Anyone can just summarize and graph data in Excel or generate some pivot tables maybe, but real value comes when you can provide actionable recommendations to your business. So obviously supported by that data that you've analyzed. Another tip, and this is becoming more important, I see this come up more frequently, is that you ought to allow your business more freedom to explore the data that you bring in. A lot of our business partners are becoming very tech savvy and they want to do some analysis on their own, right? It used to be that a lot of this work was done in silos, so you had database administrators and maybe statisticians, and the business wasn't as actively involved, but they want to be involved, right? They want to be able to do the analysis. Where we can come in is by providing them some guidance and some governance, just so it's not the wild, wild west, right? And the retrieval tools that they can use to make discoveries on their own. Another tip is to not dismiss expert advice or your gut. So some people think that analytics might eliminate the need for expertise, right? Or experience. But in a lot of cases, they can support each other or supplement each other or confirm each other. So they can work together really well. It doesn't have to be one or the other. Another tip, you should break problems down into smaller pieces and deliver data insights more often. So you don't have to solve the entire problem before you start sharing some of this information. You can build excitement as you start sharing some of the insights that come out. And if we wait too long to share information, it might be too late to make an optimal decision. Another tip, keep a data dictionary. This is just something that describes your data. It talks about the database tables that you have, the database schemas or the sources that you're pulling from, the fields in the tables and the database keys, the data types, the frequency with which you get the data, the granularity, how it's being loaded. And this will help other people as who come after you, right, who are looking to solve business problems and don't realize that maybe the data is already available. And so they may just need to look at your data dictionary to figure out if it fulfills their requirements. Another tip, don't get too rigid with your architecture. So we talk about how data is becoming more complex. It's much more unstructured. It's coming at a faster rate. And we have to have a variety of tools to be able to handle some of this. So it's not that, hammer is just not going to work. It's got to be a toolbox, right? Several things that we may need to use. And sometimes the tool that we use depends on the type of problem we're trying to solve or how soon we need to get some insights out. And one final tip, I think it's so important to make sure you master pivot tables and some of the statistical tools in Microsoft Excel. I'm not saying that you're going to use that for all analytics, but it's a great way to start exploring some of the data that you get, to do some of the research and planning that we've talked about earlier. It's a really great way to start slicing your data up and to start exploring it. Okay, so that's it. I hope that you enjoyed it, you got excited about analytics, and that you are interested in learning more. Thanks.